So many thanks for this opportunity. Thanks for the kind introduction as well. So I guess I would have around 30 minutes of time. That'd be roughly what I would shoot for. Yeah, okay. So I think, I know that this is a broad forum of engineers, not just computer scientists, engineers from all parts of all disciplines across, across engineering. So what I wish to talk about today is around three things. I've structured the talk as comprising three parts. One is a very brief history of AI, and I believe that a history of AI is important to understand at this time when AI has taken a significant turn towards claiming that it can answer anything under the sun. So earlier AI applications were very domain focused and so on. So how did it come about in this way? So I think it's very important to understand that history, and that's a very easy way to understand the technology as well, because history gives you a unique perspective into looking at technology. And then I will talk about some contemporary debates in the field of AI and digital technology in general, and then I'll talk about some ways forward towards the end. So coming on to the history of AI. So we see today, AI as being presented in a very human-like fashion. So there is a terminology for this, a very complex terminology for this. Some of you might have heard of this, called anthropomorphism. Anthropomorphism is a trend of alleging human traits to non-human objects. So this has been used in a lot of metaphors in literature and so on. So the cruel tempest or something like that. Those kinds of things are anthropomorphic terminologies. So anthropomorphism is heavily ingrained within AI, because AI appears to us as a chatbot. That is, a chatbot is usually a way to converse with a person on the other side. During our days, there were Yahoo messengers and so on, and then there's WhatsApp and so on. So it comes to us as a chatbot, an all-knowing chatbot. Okay. So the roots of AI's anthropomorphism can be traced to the very early days. In 1950. Alan Turing, who is currently known as the father of AI as well as the father of computer science in general, he devised what is called as the Turing test. Have some of you heard of the Turing test? Can we have a quick show of hands? Anybody familiar with the Turing test? Yeah, I guess not many are. But basically, think of Turing test as a test of, it's positioned as a test of intelligence. But towards understanding that, think of a WhatsApp handle. Okay, you send a message, you get back a response, and so on, and you send a number of messages after getting the response and all that stuff, back and forth in terms of text messages. And at the end of it, let's say that you make a judgment on the basis of the messages that you get as to whether that chatbot is actually a human or a machine. Okay, if the chatbot is actually a machine, chatbot by name is a machine, but if the entity at the other end of the WhatsApp handle is actually a machine, but it seems to be human to you, then it is said to have won or succeeded in the Turing test. Okay, so basically that's the idea. So a machine should give out outputs which seem to the interlocutor as if it is a human. So the judgment of whether it is a human or a machine needs to be made at the level of the outputs. You are not allowed to go into the operational model of the WhatsApp bot, WhatsApp handle in this case, and see whether it is a human at the other end or not. You are allowed to judge only on the basis of the results. So this is a significant departure from traditional pathways of automation. In traditional automation, what do? You look at a human engaging in a process, you understand how the human is doing certain activities in that process, and there is a person who observes that, and then they faithfully do that same process but by using machines. So that is the way traditional automation has worked, and this is true in the case of printing presses, for example. There used to be humans who take these little engravings and put them in order to create text and so on. So that is now being replaced by programmatic ways. So, but Turing test says that under the AI paradigm of automation, you need not look at the process. You need not look at how the human is doing and imitate the process. You only need to imitate the human outputs. Okay, so this is a significant departure, and I think I'll stress it again. It is not the automation of the process, but it is an automation of the production of outputs. Okay, this makes it very sharp. This makes a very sharp distinction between between AI and other traditional forms of automation. So Weizenbaum, Joseph Weizenbaum, who is a pioneer in AI in the 1950s, he looked at this Turing test and he characterized it in beautiful prose. He said that the success in a Turing test is determined by how well it can deceive the interlocutor. So it's a test of deception, right? It should make it look like a human, whereas it is not a human. How well it can deceive the interlocutor, and how many people it can deceive. So how many and how well, breadth and depth. Okay, how many and how well. So it is a combination of this that leads to successful AI as the way AI scientists think about it. So in order to create a general deception, so in that sense AI could be thought of as a technology of deception. It's a heavily cognitive technology in that sense. It should make it look like a human. That's the entire idea behind AI. So if you were to do well at the Turing test, then you should deceive as many people as possible. It is not about deceiving only Indians or only South Asians or only Westerners, etc. You should deceive everybody. So if you should deceive everybody, you should rely on common human endowments. Okay? Common human endowments as in what is common in the character across humans as a species. So what are those common human endowments? So one possibility was explored in the 1950s, and that was about building rule-based systems. Rule-based systems are complex, simple processing systems. For example, there was an AI chatbot which said in the 1960s, which took a question like it's a psychotherapist chatbot. Says somebody tells it I'm sad, and then it will put the question back to them and say how long have you been sad, and so on and so forth. Okay, so these are rule-based systems, and it was found that these rule-based systems can convey the impression of a human operation. So there was a person called Rose Ashby who said that as long as you obscure the details of the system and show only the outputs, as long as it is a sufficiently complex system, it will seem human. And that is a fundamental human vulnerability. This was later characterized as what is called as the ELIZA effect. ELIZA. ELIZA was the name of the chatbot as well. So ELIZA effect is the tendency of humans to attribute human character to sufficiently complex systems. And later, there was a person called Douglas Hofstadter, an AI philosopher, who said that the ELIZA effect is ineradicable in humans. So it needn't even be complex. For example, if you go to an ATM and withdraw some money and so on, and you get a little chip at the end of it, and it might say thank you. It might bring a little smile to you. It may not bring, but it could bring a little smile to somebody. So it's sufficiently complex systems, non-human systems, but you tend to feel happy when somebody thanks you. And in the same way, you tend to feel happy in seeing this complex system printing a sequence of strings which says thank you and so on. So then people explore sensor-based systems, and sensor-based systems explore the use of a common human endowment, which is basically sensory, sensory prowess, if that's a way to put it. So we have 5 senses, and we are heavily driven by those 5 senses. Right, during the COVID times when we lost the sense of smell and so on, we felt so impoverished. Right, so senses are very fundamental to human life. And so building these sensors and robotics was a very prominent paradigm of exploring how well you can deceive people, how well you can succeed in the Turing test. So even today, if you go to a simple science and technology fair or something, you see very simple robots being presented, and there's a little bot which goes and hits a little obstruction, and then it turns back and so on. So it's extremely simple operation. You go and hit it and then turn it back. It's one if-else statement in a computer science way, but still it looks very intelligent. You might look at it for 5 minutes, or you might look at it for 2 minutes and smile and comment the student and go away. But basically, the idea is that as long as you use sensors, there is a perception of intelligence that could be created, and that was a pathway that was explored during the initial years of AI. However, during the 1980s, when people started, realizing that there are fundamental limitations to this. The limitation is that you cannot do fine motor movements. Even today, there is no bot or there is no technology that can iron the clothes the way we do, because it involves a lot of fine motor movements. and it doesn't hold the broom. I mean, even there are vacuum cleaners and there are robot vacuums, etc. They don't clean the floor like we do, because our cleaning of the floor uses fine motor movements, uses the broom and all that stuff. And there is no technology that cleans dishes the way we do, right? Because that also involves fine motor movements. We never put dishes within a big enclosure and pump water into it. I mean, we take the dish and then clean it, right? I mean, these fine motor movements are very hard to reproduce, and so is the case of perception. In the sense, we look at a picture and a picture of a cat, and we cannot but quickly arrive at the judgment that it is a cat. I mean, we don't even need to think. It's spontaneous perception. These perception, mobility, and so on are very hard to come by with an AI. And when it comes to perception, for example, pattern recognition is something that relates to perception, and maybe making a quick labeling of an image, etc. All of these are perception-related tasks. And so, if you cannot program perception or mobility into these intelligent systems, what you do? The next best way is to copy human outputs. Right? You only need to feign outputs. So the simplest possible way of succeeding in the Turing test is to get the question, ask a human, and respond back with that answer. Right? I mean, that's the simplest way, because human is the making it look like human is the fundamental idea. Right? So in that sense, you could copy from humans and you will succeed in the Turing test. That is a given. So what data-driven learning pursued was this pathway towards getting human outputs and trying to reproduce it directly. Take all the programming, take all the sensors, everything out. You just take human outputs and then reproduce them, right? Reproduce them mediated with a statistical model. So for those who might not be familiar with AI, I'll give you a little two thought experiments to think about AI. So think of a large number of images. And you have a new image. You take the top 3 closest images based on some notion of similarity, and then output the majority label associated with those images. So that makes what is called as a KNN classifier. Okay. So instead of doing this, maybe later you get an image that looks a little different, and then you find some parts of the image and identify where those parts exist in the existing history, existing database of images, etc. So you kind of improve upon this K nearest neighbor a little bit, and eventually you get what is called a statistical model. So I'll give you another example. So let's say that you're building a chatbot, and this chatbot is simple in the sense that you have a history of question-answer pairs, and when you get a new question, you look up the exact question in the history as long as it exists, and then output that answer. So it's simple deception, right? When you get the question, you look at the question in your database and associate its answer. But this is a fundamental limitation. It cannot answer new questions. So what might you do? You might take the question that comes to you, find the closest question, and output its answer, right? But this also doesn't work very well. For example, the question that you have might be, what is the ancient capital of India? Whereas the question that you have in your database could be, what is the current capital of India? Current capital of India might be Delhi, and the ancient capital of India might be Kolkata. So these are different answers. So this thing doesn't work. So you do more and more things, and then you do some statistical models, and so that's kind of AI for you. And today's chatbots, I'll talk about this just a wee bit more. So have you seen this little toy called Talking Tom? The one that kids use, right? So it's very amusing. So you say something, and it says the same thing back in a different accent, slightly elongated and so on. So it's slightly funny, a funny type accent, and that makes for interesting entertainment, right? I mean, we as adults also go use the Talking Tom and find it funny and so on. Think of another kind of Talking Tom. You say one sentence, and the Talking Tom replaces one of the words in the sentence with a different word. Could be a synonym or something. So you say, you say something, and then it replaces one word, and that makes it even more amusing. Why does it make it even more amusing? Because there is more uncertainty in it, right? because which word is going to be replaced is not a given, right? I mean, that is something that amuses us. And think of it going further along this direction. And so what you output, what you input is a question, and then it finds the most similar questions and mashes up some of these patterns and returns back to you. That, if you take it 1,000 more steps, you get what looks like an AI chatbot of today. So AI chatbots are basically pattern-based mashups. So they take your question and find patterns that are related to it, and then mash them up and give it back to you. So basically that's what it is. So this entire idea of AI and consciousness and so on is quite unfounded in some ways, because it's all, we don't work based on pattern-based mashups. If somebody asks us a question, we look at whether, what is the essence of that question, and we sometimes look at the correspondence of that question to reality, to the real world and so on. And then, so our world model our truth model is of correspondence. It's not based on pattern-based answers, because 100 people might have told us one answer, but we might still want to respond to it with a different answer. That's because we have a notion about correspondence with the real world, we have an interpretation of the real world, and we have our own moral agency. None of these exist in the case of AI chatbots. So I think I'll sort of close this part, because I need to quickly get to the second part, which is more important, I think. So today, a data-based regurgitation, pattern-based regurgitation of data has gone to extremely complex levels. It uses tremendous amounts of non-linearity in the form of large neural networks and so on. But still, all this said, these technologies are different from humans. Why are they different from humans? They're different from humans for the very simple fact that humans don't work deterministically. Humans don't work as programmed. A machine or a chatbot works the way it is programmed. That is a fundamental difference between humans and machines. So in that sense, machines cannot create new history. They can work as programmed. They might be fed with new data. They can regurgitate new kinds of outputs and so on. But humans are socio-political, and we discuss things, and we might create a new world order in the next decade or something if whatever is going around in the global order seems to point to that direction and so on. We create these kinds of institutions of learning, we create professional organizations, we create hotels, we create roads, we create transport. All these are human created things, right? When humans create history, whereas technologies are about working in ways that are pre-designed and so on. So today's, I'll go into the second part, which is basically about the current debates around AI and the digital world in general. So many a time we think of engineering as basically as about efficiency, as about creating things or doing things more efficiently and so on. Right? I mean, there is an economic impetus to this, especially under the economic order of capitalism, which is about efficiency in order to generate more profits. And this should necessarily lead to improvements in what is called as productivity, right? I mean, so there was an observation in the 1990s, and this was around 20 years after computers had made their way into everyday life and so on. Not everyday life, into certain sectors of economic activity, and that was called as the Solo's paradox. Have you heard of this Solo's paradox? It is called as a productivity paradox. Solo was a person, an observer at the time, a thinker at the time. He was saying that computers can be found everywhere, but not in productivity statistics. So this was a significant problem. I mean, if you're using computers and if you believe that everything has become more efficient, productive, etc., but you don't see this in productivity statistics. There is a similar problem today, that AI is everywhere, but AI cannot be seen in productivity statistics. We talk about productivity increasing, turbocharged in the case of AI, but if you look at macro level economic statistics and so on, there is no improvement, there is no significant improvement in productivity statistics when it comes to the AI world. So this is sometimes called as the AI productivity paradox. So different people have responded differently to this very interesting question. What is going on? I mean, there is a lot of AI, so it's making things efficient and so on, but we don't see that in productivity. So what is going on? So one of the ways that people have tried to reconcile is this theory called techno-feudalism. I believe some of you who are from Kerala might have heard this because it was part of a public debate, public discourse for some time. But basically, techno-feudalism is the idea that these big tech companies have created empires. So these are feudal empires. So think of Amazon. Amazon has created an empire. Whatever activity takes place in Amazon, Amazon gets a cut of it. Right? I mean, if you sell something on Amazon, Amazon gets like 10% of it, whatever it is, right? So people think of these as empires. I mean, I'm not subscribing to that view, but I'll tell you why I don't. And they talk about Facebook as an empire. Facebook is an empire with tremendous amounts of AI, personalization AI, matching AI, and a lot of profiling of posts based on emojis, likes, comments, and the content, and all sorts of. It's a completely AI-based platform, or Instagram for that matter. Meta, the entire Meta, the company Meta's stack for that matter is AI. But the techno-futurist argument is that whatever you do in Facebook makes money for Facebook, right? So they say that you are paying a little bit of rent. I mean, you may not be paying rent in Facebook, but the advertisers are paying a little bit of rent for Facebook because they're creating this empire, and if you operate in that empire, you need to pay some rent. And Amazon is extracting rent from buyers as well as sellers. I mean, the buyers might pass on the thing to sellers in the way of higher prices, etc. But there's a fundamental problem with this idea. The idea here is that the rent thing, I mean, the assumption here is that these digital empires are worthy of rent. Are they worthy of rent at all? I mean, are they worthy of extracting rent from people who operate within that? So this is where we must see this in a sort of a different angle, if I may. I mean, I have my opinion about this. You might disagree or agree, but I will nevertheless tell you what I think. So let's look at the spaces where AI works, right? I mean, when you look at the spaces where AI works, I mean, AI companies largely draw a significant part of their revenue from advertising, right? So I mean, what is the largest revenue stream for Google? It is advertising. It's on 78% of revenue. And then for Meta, it is advertising. So it's all about advertisers, right? So where does money in advertising come from? So if you walk around Kochi, you find a lot of billboards, right? Where does the money for building these billboards come from? The money, if the billboard has an ad of a biscuit or something, the display of that ad is funded by the biscuit company, right? Or if it's an ad for something else like a car, the price for that ad is paid by the company which sells cars, right? When it comes to intermediaries and so on. But the fundamental value transfer is that the car producer makes some profits, and some of their profits goes into funding these advertisements. And for example, the likes of Coca-Cola and Pepsi, a large fraction of their profits go into funding advertisements. So in a similar way, if Facebook is an ad company, I mean, in a way it is an ad company because it's they tend to tell us that it's a social media company, but economically speaking, because their revenue source lies in ads, they are an ad company. And if you have friends in Meta or if you have friends in Google, etc., I mean, you ask them what they do. I mean, most likely it would have something to do with ad matching or ad profiling or ad auctioning and all those kinds of things. So basically, if you look at it from that perspective, let's say that you spend 10 minutes on Facebook. What does it actually do? In the 10 minutes that you spend on Facebook, you see some ads. And by seeing those ads, you're tempted to buy those products that are advertised in those ads, right? So the product companies which make these products are